without writing it all out in a tree diagram form. Because doing that tree diagram, while it's nice to do when we have lots of different options, it's really hard to do every single time because that would just take up too much space and you would need like a whole wall to write things out. So we need a better way to figure out how many options or total outcomes we have. All right? At this point, if you have your phone out, put your phone away, set it aside. Phone, up daisies. Thanks. Adrian, put your phone away. Adrian, phone away. Notes out. Thank you. All right, great. So, fundamental accounting principle tells us if there are M options for the first event, so M here we're using as a variable, meaning it's a number. So like we'd have like 2 options or 5 options for the first event. And N then our total outcomes is M times N. So we multiply how many options there are for each event or each decision we're going to make, and that will give us our total amount of outcomes. So then when we find probabilities, it goes a little bit faster because we won't have to write out all of those options. Yeah, we'll talk more about finding those probabilities in J4 and J5. Today we're just going to worry about total outcomes. Give you a little bit longer to write that down. That was kind of a lot. That was like, what? Can you get your notes out? At least pretend to do class. Get your notes out, write your stuff down. Start getting ready for class now that we're 10 minutes in. Alright, we're going to do 3 examples here, and then you'll have the rest of the time to do your quick check. Pretty short today, short and easy. Practice of J1, 2, and 3. Alright, so example number 1. I'm going to think about rolling a dice 7 times. So each time I roll a dice, that's an event. That's a new thing. Okay. Struggling to find my dice here. I don't know where it went. Alright, so when you talk about a dice, remember we're talking about the little cube with the numbers on it. Okay, and I want to know how many options are there. How many different ways can I roll a dice 7 different times? And it's going to be quite a few times because each time I roll that dice, how many options are there? How many sides are there on a dice? 6. Each time there's 6 options. Remember, you could get a 1, 2, 3, 4, 5, 6. Okay, and I'm going to do that 7 times. So on my work here, I'm going to do this how many ever times we're rolling the dice. So on the first time I roll the dice, how many options are there? What? How many different numbers could I get? 6. So 6. That's my first time I rolled the dice. Times. Now that I roll the dice again, how many options are there? Did it change? No, there's still 6 sides. So times 6. That's 2 times. And I need to do this 7 times. So I'm going to do it again, times 6. That'd be 3 rolls. I'm doing it 7 rolls. So 4 rolls, 5 rolls, 6, and 7. You should have 7 6s there. Because each time I roll the dice, how many options are there? 6. So 6 times 6 times 6 times 6 times 6. And we want to find out how many different outcomes are there, how many different possibilities. Okay? We know a different way to write this instead of writing it as 6 times 6 times 6 times 6 times 6 times 6 times 6. How else can we write that repeated multiplication? Good. 6 to the power of 7. And that might just make it a little bit easier for us to type it. Okay, you could write in 6 times 6 times 6 times 6 times 6 times 6 times 6, but that gets we get a little lost. So we're going to do 6 to the power of 7, and we get 279,936. 279,936. That's the amount of outcomes there are. So first I could roll a 1, then I could roll a 3, and then a 3, and then a 5, and then a 2, and then a 6, and then a 7. I'm just kidding, can't roll a 7, and then a 1. Okay, or I could almost do that whole thing and just change one outcome, which means that's why there's so many. If we were going to create a tree diagram, we would need it to be like 1, 2, 3, 4, 5, 6. Then each of those 6 would have to split up into 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have to keep going. So we'd end up with 279,936. Making that tree diagram would be not super fun. Okay? Probably would make our computer do it. All right, number 2. Again, we're only doing 3 examples, so we're almost done. Insane. Number 2, we're going to talk about taking a test. Okay? On a test, we're going to say that the first 2 questions are true or false. And then there's going to be 3 questions that are multiple choice. I want to know how many different versions of that test. If you just were going to randomly guess answers, how many different ways could that teacher create a test with the right answers? Okay. For our multiple choice, we need to know how many options there are. Let's say that we have an A, B, C, or D. Okay? And that's just how the test is made. We didn't come up with that. That's just what we're given. Information we have. So to find our number of outcomes, this time when we think about each event, each thing that's happening, we're looking at each question. So how many questions are on this test total? 5. We have 2 questions that are true or false, 3 questions multiple choice. So we're going to have 5 spots. So I have question 1, question 2, question 3, question 4, and question 5. I'm going to be multiplying each of those options for each of those questions. And to know how many options we have for that question, we're going to ask what type of question is it. So in question 1, what's the type of question we have? True or false? So how many options do you have to answer that? 2. Either you answer it true or you answer it false. There's 2 options for a true or false question. How many different answers are there for question 2? What type of question is question 2? Yeah, true or false again. And true or false, how many different answers is that? 2. Because it's either true or false. All right, question 3. What type of question is question 3? Multiple choice. And how many different answers do we have in our multiple choice question? 4. So we have 4. How many options do we have for question 4? 4. It's another multiple choice question, and we had 1, 2, 3, 4 options. And what about question 5? 4. At this point, all we have to do is multiply that. So we're going to do 2 times 2 times 4 times 4 times 4. And we get 256. 256 ways, or 256 outcomes in this case. All right, last one we have is number 3, problem 3. And now in the number 3, we're going to talk about passwords. Now this problem 3 is actually going to have 2 different parts here. All right, if we're going to talk about passwords, let's pretend it's a 4-letter password. And we're using the English alphabet. But we have 4 letters for a password. Now there's 2 options here. Yeah, or if you want to just, we're like on the last problem, so if you just want to wait, and then I can just give you the notebook. Alright, so if I have a 4-letter password, there's 2 options here. Your password, they might say, yep, it's okay to repeat a letter. If repeats are okay to do. So it's okay to have a password that's just A. Generally speaking, is that a good password to have? A.
No.
Probably not. Even like ABCD is probably not a great password. But let's just see how many passwords, how many possible outcomes are there if it's okay to have repeats. So we have 4 letters. How many letters are there to choose from in the English alphabet? 26. So there's 26 letters in the first one. Now I can reuse that same letter. So how many are there to choose from in the second one? 26 letters. And how many letters are we doing for our password? 4. So we can do 26 again. And we can do 26 again for another one. So it's 4 letters, but each time we pick a letter, there's 26 letters to choose from in the alphabet. Yep. And I asked him to get caught up on his notes first. All right, so how else could I write that 26 times 26 times 26 times 26? 26 to the 4th power if we wanted to. That one's a little bit easier. We could type it in our calculator as 26 times 26 times 26 times 26. 26 to the 4th power. We get 156,976. So if you were going to by hand try to crack someone's password and try and figure out by hand what their password is, how long would that take you to type in 456,976 options? Like you'd have to type in A, enter. Nope. A, enter. Nope. A, enter. Nope. How long would that take you to try and break that password and try and figure it out? Probably a while, right? Not quite a year, but it would take you a while. But that's why we have computer programs that if you're a hacker, your computer program is trying to do it, and they do it much quicker. Okay, so speaking of that, if a computer program is doing this, that's not a lot of passwords, 450 for a computer program to go through. So that's why making a longer password is going to be important. Or using like uppercase and lowercase number letters. If you have uppercase and lowercase letters, now instead of 26 to choose from, you have 52 because you have the lowercase letters and the uppercase letters. Then you add in the numbers and the complex you can make your password, the more it'll be harder for a computer to guess. All right, we have one last part here though. So in this case, it was okay to have A, B, F. It was okay to repeat the letters. What if we say that there are no repeats? So once you use a letter, you can no longer use it. For that first letter in your password, how many letters do we have to choose from in the alphabet? 26. But now whatever letter we chose, we can't use it. So let's say we chose a J. The J is taken out. We no longer can use the J. How many do we have now to choose from? 25. Okay. Once I use that letter, can't use it anymore. It's taken out. It's out of the alphabet. So now how many letters are there left to choose from? 24. And how many would be left for the last letter? 23. Yep. So should this result in more passwords or less passwords than when repeats were okay? Less. Yep, because we're taking out all those options that had those repeated letters. Good. All right, so in my calculator, all we're doing is 26 times 25 times 24 times 23. And we get 358,800. So if you were a computer programmer and you're creating a program where people had to create their own passwords, would you want the people to be able to repeat letters or don't repeat letters? What would be more secure? What would be harder for someone to guess? Yeah, repeat, because there's more options. Okay, so some of you that like maybe you join a website and it makes you change your password like every couple of months or every year, and you're like, oh my god, that's so many passwords to remember. It's really just for your safety to make sure no one else can get into your account.